We're recording. So we are now doing what's going to be the rest of the first part of the z-scores lesson. We'll get to the final z-score lesson, part 2 of z-scores, on Monday. And then Tuesday will be review day. Wednesday we test. That's it. This unit's pretty much over. We're down to our last lesson and a bit. So let's take care of the bit. So remember yesterday, we had a very common situation in statistics. Two people from two different schools are being considered for the same, perhaps, scholarship or whatever. And Madeline scored 205 on her test. The mean of that test was 190. The standard deviation was 8. Sarah scored 91 on her test, but the mean was 81 and the standard deviation was 4. Who had the better score? And we figured out that the z-score for Sarah is bigger, which meant that her placement, there's Sarah on the right, is further to the right on this cumulative graph of frequency than Madeline. In other words, there were more people in Sarah's class behind her than were behind Madeline in her class. So Sarah is objectively the stronger student. Now this, of course, assumes that the two classes can be relatively compared the same, right? They had the same number of hours in their day and same number of classes in their semester and all the other little things that might make it unfair one way or the other. Assuming, again, it does say at the beginning of the question that they're equally reputable. So assuming the classes and the tests are equally reputable, Sarah's the better student. But we still have kind of one question I kind of wanted to answer. What percent of the class did Madeline beat versus what percent of the class did Sarah beat? Now we know Sarah's is higher, but we don't know the exact number. Like if she was right on this line, right? If she was right on the middle, we know she beat 50% of the class. If she was right on this line, she beat 50% plus, remember this bar here is 34%. But what happens when you're not right on one of those lines? That's what we're going to learn how to calculate today. What percentage does a z-score correspond to? So go to the next page here, and we'll start with an example that is a standard normal distribution. Remember what standard normal means? Standard normal means it's kind of a blank slate. The mean is 0, and the standard deviations are 1. So calculate the area of the shaded region under each of the following standard normal distribution curves. Okay, I'll go through the TI first because this one's kind of complicated. For once, Desmos is way easier than the TI. Okay, well, not way easier, but it's easier. Okay, let's do the TI first. So for the TI, we're going to have to give ourselves a 4-number summary. Different TIs actually do this differently too. If anybody here, I know that I have a couple of people with the TI-83 Plus, which is what I'm using, right? I'm using the TI-83 Plus. I think it's a plus. Oh, come back. I opened it, I closed it. There we go. Yes, it's a plus. If anybody here is rocking the slightly higher version calculator, like a TI-84 or a TI-84 Plus, it's actually easier than what I'm about to do. When you do what I'm about to do, it opens a menu for you and tells you what numbers to put in. Okay, now before we get into what we actually enter and what buttons we punch, let me just remind you of something about the standard deviation curve. We saw this in one of the videos we watched. Remember that this curve is never going to touch the x-axis. Remember we had a cool conversation about that. It's like, so it goes on forever? Yeah, it actually goes to infinity. What button on my calculator is infinity? You got an infinity button there? No, you don't. So how do I tell the calculator I'd kind of like the boundary on one side to be forever? Well, we're going to trick the calculator into thinking it knows infinity by making the calculator think about the biggest possible and the smallest possible numbers it can handle. The biggest possible number that the TIs can handle tends to have 100 place values in it. So do you mean you're going to actually ask us to type in 1 and 100 zeros? Or 1 and 99 zeros? Well, there's a shortcut for that. How many people remember numbers like this? What do you call that? You call that? Close. It's called scientific notation. Remember that from your science classes? So that's scientific notation. What that is that's a 1 followed by 99 zeros. It's a 100-digit number. And it's actually really easy to type in. This part here has a shortcut button on the calculator called EE. So when I am trying to find how much area there is under this, I need to tell the calculator 4 numbers. I need to tell the calculator, and it's written in the notes there if you just look off to the side. I need to tell the calculator, let me close this up here a bit. I need to tell the calculator the lower boundary, comma, the upper boundary, comma, the mean, comma, and the standard deviation. So for this example, what's the smallest number going to the left forever? What's the lowest boundary? Well, it's negative infinity. But the calculator doesn't have an infinity button, so we're going to enter -1 times 10 to the 99. But we have a shortcut way of typing that in. It looks like that. I'll show you how to type that in a sec. The upper boundary, we want all of the data up to the number 1.8. So that's my upper boundary. The mean of this is a standard normal distribution. So the mean is 0 and the standard deviation is 1. It's an E. So let me show you where that is in your calculator. So all the guys who are using TI calculators or the pirated version of the TI calculator on your phone, and can you please move and stay where I put you? There we go. Okay, so turn your calculator on, and you are going to hit, okay, now there's two different ways we can do this. If you only want the numbers, you don't care about this graph, I'm looking at the graph. Do I need the graph? Not really. So if all you want is the numbers, you go to, and I actually didn't write this in your notes, you might want to write this down. You go to second function, vars, and you go to number 2, Normalcdf. So the thing in front of this bracket is called Normalcdf. Normal meaning normal distribution. C stands for cumulative, and then F frequency. So it's Normalcdf, normal cumulative distribution function. There we go, that's what it stands for. So on my calculator, it's second function vars. So here, let me start it again. Second function vars, number 2, Normalcdf, and then you enter those 4 numbers. So here's the E button. First of all, we need -1. Make sure you're using a negative, not the subtract button. -1. And this button is the times 10 to the button. So second function EE. Can you see that? It's on the comma. It's the second function of the comma on this calculator. 99. So I just told the calculator the lower boundary is -1 with 99 zeros, which is a heck of a long way to the left. That might as well be infinity. Comma, 1.8, comma, 0, comma, 1. Close my brackets and hit equals. And there's my answer. This shaded part is 96.4% of the data. Makes sense, right? Remember that standard deviations between between 3 standard deviations left and right is 99.7. This isn't quite that far over, so it's 96.4% of the data. Okay? Now, I told you there was 2 ways to do it. This is the way I wrote on the notes. What if you actually want to see this graph? What if, in addition to finding out what the percentage is, I want to see the graph of the normal distribution? Here's how I do that. Okay, I'll clear this. And then I'll follow the instructions the way I've written them on the page here. So they're on your page right here. Follow those. Okay, now before I start though, I'm going to need this to fit in the window. It's actually easier to set the window first. Okay, what kind of a window is this if I want to graph this? So, okay, so for A, let me just write this in words. To see the graph, and again, you might want to write this in words, set the window to, and then, okay, so let's see, what kind of a window would show me all of this data? So let's see, what would the X minimum be good to be? So how about the X minimum? Well, remember that by the time you've hit the 4th or 5th standard deviation, you're talking about such a small amount of the graph, you wouldn't even be able to see it. It'd be smaller than a pixel. So how about we go from -5 to an X maximum of 5? Okay? What scale should I count in? Remember, SCL means scale. Count by ones, so the standard deviation counts by ones. How about for Y? Now, I actually know what's going to happen before you. It's going to draw me the graph, and it's going to give me this answer of 96% at the bottom of the graph. So I want the graph to have a little bit of room under it for that answer without getting in the way of my graph. So I'll set the Y minimum to, like, I don't know, -0.1 is actually, that's probably enough room. I might change my mind about that, but I think it'll be that. Now for the Y maximum, remember that all of this adds up to 1. So this height here, if you say 0.4, you've probably got lots of room. So 0.4 is a good number. And for the scale for Y, the Y scale, count by, I don't know, 0.01s or something, 0.05s, anything like that's good. So this is my window setting. So I'm going to set my window to that. I honestly don't remember what my window is sitting at. Oh, and remember, we did this when we were making histograms too. Make sure there's no other graphs happening at the same time. So go to your Y list, make sure there's no equations. Good. Make sure that your stat plot is off, so it's not trying to graph something else at the same time. These calculators have limits. They can only graph so many things. Okay, good. So stat plots are off. There's no equations in the way. And now follow the instructions that I've written on the page here. You go to second function, vars. This time I want it to draw the graph. So I go over to draw, and this is a normal distribution, so it's shade norm. And now I enter the same 4 numbers that I entered before. Oh, but I forgot. Did I actually set the window to this? I'm sorry. Let's do the window first. Oh, no, my window is nowhere near that. Oh, no, it's actually pretty close. I'm sorry. It is close. It's -5, 5, scale of 1. I said the X minimum. Actually, I set it to 0.2. So, okay, so maybe set it to 0.2, not 0.1. I'm changing my mind on that because I did this yesterday. So -0.2. And my Y maximum, oh, I went to 0.5, not 0.4. Actually, I don't think this will make much of a difference, but okay, fine. And then my scale, I actually counted in 0.01s. That wouldn't matter. Okay, we're good. So quit that, and let's go back. So shade norm. So again, how did I find shade norm? Second function, vars, which is distribution. Draw, shade norm. And then I put in the same 4 numbers that I put in the last time. I say -infinity, and I say -infinity by going -1 times 10 to the 99. That's how I say times 10 to the e. Comma. What's my maximum? What's the boundary I want to count to? I want to count all the way up to 1.8. How much data is left of 1.8? That's my upper boundary. Comma. Mean, 0. Comma. Median, standard deviation, 1. Close my brackets. When you hit enter, it should automatically go to the graph screen. And there we go. It's doing it. And you know what? I'm going to clear it and do it again. Second function entry. equals, and for some reason it's not clearing my old graph, and I don't know why. This is the graph I made yesterday. It's giving me the right answer though, 96.4%, but it's not showing me the little bit that's empty because I had a different graph there yesterday. Clear, 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 clear. So let's go back to graph, clear the graph. Let's go back to entering stuff. Second function, entry equals. Why is it not clearing the graph? Delete, graph, clear, delete, clear, enter. I don't know why it's doing this, but anyway, it's making me a very lovely bell curve, but it's not clearing my old graph. Let's go to StatPlot. Is it in StatPlot? No, everything in StatPlot says off. Well, that's curious. Clear that. Plot 1, plot 2, plot 3 are all off. I have no idea why it's not clearing my shade. How about we just delete everything, clear everything. Okay, so clear everything and start over. So what if I hit graph? It's still there. How do I make this graph go away? Okay, I'm gonna have to look at this. I honestly don't know what I'm doing wrong. Delete, quit, graph. Why will this graph not go away? If I ask it politely, will it go away? I don't know why it's doing that. Okay, I will look into why that's happening and get back to you. Guys who are working on a TI, are you having this problem?
Yeah.
You have an old graph that won't go away?
No.
Yeah, you can't. Okay, so I don't remember how to get rid of it. So there must be something we're doing wrong. Okay, anyway. Sorry, what's that? Oh, we're going to do that right now. We're going to do that. Next is Desmos. So for the Desmos people, here's how it works on Desmos. For Desmos, you go to normal distribution. So go to the functions page, and under distribution, go to normal distribution. Okay, now normal distribution will look like that, right? There's the bell curve. Doesn't look like much of a bell curve right now, but remember, I can hit this zoom fit button on the top left, that magnifying glass, and there, now it looks like a nice bell curve. Isn't that nice? Okay, so let me start that over. Go back, starting from scratch. Go to functions, normal distribution, and then hit this zoom fit button up here. And there you go. You got a nice normal distribution, right? Okay, now what do we want again? We want to go and we want to find the cumulative probability. Right now it's assuming that it's a mean of 0 and a standard deviation of 1, which it is. And we want to find the cumulative probability, so click on that. And it assumes we start at negative infinity and go to infinity, which is 100% of the data. Remember, 100% is 1 when you change it to decimals, right? So we want to go from negative infinity up to 1.8. So type in 1.8, and there it is, 96.4%. See, that's a lot less complicated than the TI calculator. Okay, so let's try the other examples on the page. So let's erase this guy, or actually we don't even need to erase him. Let's change it to the next one. The next one, for the next one we want to know the shaded area to the right of 1.5. How much of the data is this? What percent is it? I don't know. So we're going to find it using, first we'll do the TI. And again, do I need to see this graph? Not really. So I'm just going to use the calculator part, not the graph part. So second function, distribution. And we're doing number 2, a normal CDF. And this time, okay, so this time my lower boundary is 1.5. My upper boundary is infinity. 1 times 10 to the, which is E, 99, comma, 0, comma, 1. Mean of 0, standard deviation of 1. Enter. This is, now careful, that's not 66%, right? That's 6.6, or actually I guess rounded at 6.7%. So this is 6.7% of the data. So there it is on a TI. Desmos, all I have to do in Desmos is change this number to the lower boundary. What was the lower boundary again? 1.5. And I changed the upper boundary. Now, what's cool about Desmos is you don't actually have to enter infinity. And again, I don't think there is an infinity button. Just clear the number that you have, and it assumes that you want infinity. Like just click somewhere else and you'll see it puts infinity back for you. Oh man, I wish I could make that keyboard stop popping up. I don't know how to do that. What's that, sorry? There isn't really, as far as I know, an easy online app beyond Desmos. So Desmos is the easiest one, so that's the one we're going to use. The question was, is there any of our other online apps that'll do this? I don't think so. At least if there is, it's not as easy as this one.
So if we're trying to find the right side of the graph, we put the minimum of the number we're doing.
Correct.
On the left side, and if we're trying to find the left side of the graph, we're putting it on the maximum?
Correct. The question, because I'm sure the people at home can't pick that up on the microphone, is if we're looking for the left side of the graph, then our maximum number is the 0.7. If we're looking for the right side of the graph, our minimum number is the 1.5. And on the TI, this one is 1.5 comma positive infinity, which is 1E99. And this one will be negative 1E99 comma 0.7. Question? Yeah, round wherever. I just went with one decimal place because it seemed reasonable. Okay, we haven't actually done C yet. So whatever technology you're using, try it and see if you can figure out what % this shaded region is. Okay? So whichever technology you're using, I'll give you a second. Can I redo B? Okay, so which technology would you like to see? Okay, so on to Desmos. So starting from scratch, here's Desmos at the very beginning. Okay, so normal distribution. Okay, make it pretty. Okay, so starting from scratch, under functions, normal distribution under distributions. Okay, and then, okay, and it gives you a bell curve with a mean of 0 and a standard deviation of 1, which is what we want for this example. We would like to find the cumulative frequency, so click on that little button. And then on the second example, in the B example, we are starting at 1.5, and we're going to infinity. So there it is. It gives us the number. This shaded part is 6.7% of the data. Okay, so let's do the C one together. The C one starts at negative infinity, so just make that, just click anywhere else and you'll see that it automatically goes to negative infinity. But this time I want the maximum to be 0.7. So 0.7. Did you get that number? 75.8% of the data? Okay, and again for the TI people, on, I go, what's nice, here's a nice trick for TI. I just did a calculation like this, so hit entry, second function enter, and then just go back and edit and change it to what you want. So I'm going to go back and change. The 0 and the 1 can stay. Oops. The 0, oh boy, that's going to be interesting. The 0 and the 1 can stay. But this now has to start at negative 1 to the 99, comma, and then we're going to 0.7. Oh, and then I don't have enough space. I still have to type in 0 and 1. And then end my brackets. And this should be, what is this, 75.8%? Sweet. And if I did want to see it, if I did want to see it, how do I clear? Oh, wait a minute, I bet I know. Go to second function, vars, Normalcdf, enter, and then hit clear. No, that just made it go away. No, that's still there. Okay, second function vars, this is really bothering me. Draw, shade norm, and maybe delete. Nope. I'm going to have to figure that. I'm going to have to research that. I don't know how it works. Anyway, if I did want to see this graph, I go to second function, distribute, which is vars, go to draw, go to shade norm, and then type in my three numbers again. So I'm going from -1 to the power of 99, or 1 times 10 to the 99, all the way to 0.7, comma, 0, comma, 1, close brackets, equals, and there it is. There's my answer, you can see. Oh, no, it's still giving me the old answer. Yeah, I'm going to have to figure out how we get rid of that. Question? Yeah, the second way is just showing the graph, and there is a way to make the graphs go away, but I don't know what it is.
And it's just using that equation that's written.
Yeah, it's the same 4 numbers.
For everything?
For all of this kind of stuff, it's the same 4 numbers, yeah. Okay, so clear, but then when I hit graph, it's right back. Draw. Oh, wait a minute, is there a draw clear in here?
Yeah,
There it is. Found it. I bet this is it. Okay, guys with TIs, look up here. Go under second function, and then under programs, see the program button? Above that it says draw. Clear the old drawing is number 1. Hit enter again, and I bet when I hit graph, my graph's gone. Ha! Pig, now it's gone. Okay, so now, let's do that again. So I want to draw this example right here. So I go second function vars, draw me a normal shaded from -infinity, comma, to 0.7, comma, 0, comma, 1. And again, the 0 and the 1 stand for the mean and the standard deviation. Close my bracket and hit equals, and now it's going to draw me a good graph. You better. There it is. Beautiful. And then at the bottom, it tells me that that is 75.8%. Now, if I want to draw something else, I have to clear this drawing. So I go second function, draw, clear all drawings. There it is. And again, if I don't need the drawing, I don't need to use shade norm. I can just use calculate the distribution using number 2, Normalcdf, and the same numbers, -1 E99, comma, 0.7, comma, 0, comma, 1, close brackets, equals there it is, 75.8%. Okay, now, next, what if it's not a standard normal distribution? Actually, let's go back to Sarah and Madeline. What if, again, I wanted to know what percent Madeline is in her class? In other words, what percent of the class did worse than Madeline? What percent of Sarah's class did worse than her? All that's changed is that the mean isn't 0 and the standard deviation isn't 1. On Desmos, all I got to do now is change up here. So let's just redo that. So go to normal distribution, and I change this now to, let's see, for Madeline, looking back at the notes, her mean was 190, I'll just type, 190, comma, and her standard deviation was 8. And okay, it's like you might be going, well, where did my graph go? Oh yeah, well now that my mean isn't 0, the graph moved way over to the right. It moved over to 190. Again, click on zoom fit and it'll find the graph for you. It just moved over to 190. Now, find the cumulative probability. Sarah beat all the people from negative infinity up to her score, which was 205. Or sorry, no, this is Madeline. Right, Madeline, so there we go. So Madeline beat 96.96. So let's say 97% of her classmates who wrote this exam. That's pretty good.
It doesn't show my graph, but it shows you like the 96.9.
Yep. That's because now it's, you know why it's not showing you the graph? Because the window's set for back when it was tiny little mean of 0.
Oh, got it. Yep.
So we can change the window on that. I'll get to the TI in a minute. So this was 97% of the data. Are you telling me Sarah did better than 97% of her classmates? And the answer is, well, we kind of know she did because she's further to the right. But let's see how much that is. Go back to Desmos. And all I got to do is change this to, okay, Sarah had a mean of 81 and a standard deviation of 4. And now again, that's not where the graph is, but it'll find it for you if you hit that. And Sarah scored a 91. And that is higher. She's almost 100%. She's 99%. Less than 1% of her classmates did better on her exam than she did. So that's why she gets the scholarship.
Get that girl to Harvard.
That's right, yeah. Full ride academic scholarship for Sarah. Good for her. She's in the top 1% of her class. Okay, let's go to the calculator and do that. So for the calculator, you know what? I'm going to play with the window first. I know that that X is no good for Madeline's data. Madeline's data has a mean of 190. So that means that I should maybe go back to about, oh, I don't know, how about negative 170? And let's go to a maximum of about, I don't know, how about 220? Because 190 is right in the middle of that. For the scale, you know what we're counting by in the scale? We're counting by the standard deviation. The standard deviation is 8, so we'll count by 8s. I don't need to change the y scale because the y is still percentage. So leave the y minimum, maximum, and scale alone. And then first of all, let's make sure we cleared the old drawing because now I don't remember if I did.
Yeah, you did in the end.
Okay, there we go. It's done. It's done twice. It's double done. So now I'm going to go and I want to draw this graph. So this is Madeline's graph. Draw a shade norm. And we want to go from negative infinity, comma, to 205, which is Madeline's score, comma, her mean was 190 for her class, and the standard deviation was 8, close brackets, and okay, calculator, draw. Draw properly or die. Come on. Oh, okay. It's there. It drew. Okay, my window's still not very good. My window is way too small. So I would change my window to, let's see, we don't need the y to be nearly that tall. So the y maximum could be like a third of this, maybe 0.15. And I went way too far on the x minimum and the x maximum. I could maybe make this 180 and say 210. And then let's graph it now. Now what does it look like? Is it still thinking about it? Oh, you know what? I might have to go back and make it draw again. Enter. There we go. Draw. Okay, let's play with the window some more. Let's see. I'm still way too far to the right. So I'm gonna make this. Let's see. So the y. Oh wait, this is supposed to be a negative. Why do I have a negative on it? Sorry. Oh yeah, you're right. Okay, there. Now graph. There. Now let's graph it. See what happens.
I was like looking at this whole thing and I was confused by
Oh, and again, you know what? It redraws it every time you hit enter, so you got to redraw it. There we go. There we go. That's looking like Madeline's graph now. I still have way too much room at the bottom and way too much room at the top, but you get the idea. What's that, sorry? Okay, so for normal CDF, if I don't care about seeing the graph, clear all this, I just want to calculate it. Normal CDF. Let's do Sarah's now. Okay, so let's do Sarah's. So Sarah goes from negative infinity up to her score, which was 91, comma. What's the mean of this data? 81, comma. What's the standard deviation of this data? 4, comma. We're expecting 99%, and that's what we get. Okay? So those 4 numbers are how you do it. Lower boundary, upper boundary, mean, standard deviation. Okay, let's do the next example. So the next example is after Madeline and Sarah and after these guys that we did. The average age of males who ride motorcycles in Canada is 35 with a standard deviation of 6.3. Let's put some numbers on a graph. That means the mean goes right in the middle, 35. One standard deviation would be 35 plus 6 plus 3, which is 41.3. 2 standard deviations would be 41 plus 3.3 plus 6.3, which is 47.9. No, sorry, 0.6. 0.6. And then let's go back the other way. The other way would be 35 minus 6.3, which is 35 minus 6.3, 28.7. And then take away another 6.3, and you get to 22.4. Okay, so there's what the graph looks like. What percent of males are younger than 45? So 45 is about here. Maybe I'm just estimating. So what is this shaded region? And again, my apologies for not being able to shade within the lines. I didn't go to kindergarten. So there we go. What is that? Well, if it was all the way up to this line, it would be 50 plus 34 plus 12.5. So I can get myself an estimate like what I'm expecting. 50 plus 34 is 84. 84 plus 13 and a half. 84 plus 13 is 97. So I'm actually expecting, if it was up to this line, it'd be 97 and a half. But it's not quite at that line. So I'm expecting less than 97 and a half. So let's see what we get. I'm going to use Desmos. Okay, so my normal distribution, there it is. And I am going to type in, so let's see, what was the mean for this data? The mean for this data was 35. The standard deviation was 6.3. And the question I'm trying to answer is, what's the cumulative probability from negative infinity to 45? What percentage of bicycle riders or motorcycle riders are less than 45? And there's my answer. Oh, hey, but where's the graph? Oh, yeah. Change it, and it finds the scale for you. And it's 94.4%. Let's do it on the TI. No, I'm not redoing that. No. Because I've done it 3 times now. Okay, so let's go to the TI. I'll come back and I'll do it in a minute. Let me get the TI guys going. Okay, so for the TI guys, clear, clear, clear. Do we want to see the picture too? Sure, why not? We'll get the full treatment. So second function draw, clear all drawings. Done. Okay, so we would like to distribute and draw, shade norm, a lower boundary of negative infinity, so negative 1E99, comma, up to 45. My data had, what did my data have again? My data had a mean of 35 and a standard deviation of 6.3, close brackets, and hit enter. and it's going to try drawing it. Oh yeah, I forgot to set the window. Never mind, it gave me the answer. There's that 94.7. And if I want to see the graph itself, I have to think about my window. I could try doing zoom stat fit. Let's try zoom fit, see what happens. No, it doesn't like that. What if I go zoom stat? Will it find it for me then? No, not good. So let's see, what is our actual window here? Well, let's see, the middle of this data was 35. So maybe go from 30 to, actually 30 is not enough. Maybe go from 15 to a ripe old age. Any 75-year-olds still riding motorcycles? We'll put 75 for the upper boundary. And our scale is 6.3. And we'll leave those numbers alone for the Y scale and see what it looks like. So go back to my graph. Actually, go back to the graph. Now that I look at it, this window is way too. The Y minimum should be maybe negative 0.2, negative 0.02. So there we go. Graph. Oh, that's right. It doesn't draw it for me unless I go back and hit enter again. And let's see, does it draw it? There we go. That's pretty good. And there it is. Okay, question. Yep. Remember that if I don't care about the drawing, all I want's the numbers. The easier way to do it is to go and just ask for a normal CDF, which is 2 on that, and then enter the same numbers. Negative 1 EE 99, comma 45, comma, they're getting mesmerized by watching their calculator draw. 6.3, close the brackets and hit equals, boom, 94.3. Okay, so there we go. Now, why don't you guys try the next one? Whichever technology you're using, I'll go back to Desmos, but I'll give you a second. The next question is, I guess I haven't written down the answer to this question yet. This is 94, oops. This is 94.4%. What percent of males are younger than 21? That would be, remember, this line was 22.4. This should be really small. This should be really tiny. Ah, there's people going, wait a minute, I did it and I got a big number. You probably counted the wrong way. We want younger than 21. So all I'm changing on Desmos is one thing. The maximum is now 21. There we go. And how do you read that? Are we good at reading decimals to percents, everybody? 1.3%. It's pretty small. Is that reasonable? Probably. You know what it is? It's probably, I mean, motorcycles are so expensive. It pretty much takes a middle-aged guy with a good job to be able to afford one. I'd be willing to bet that this average age of 35 is probably too small. I see a lot of older guys on motorcycles in my neighborhood. I haven't been on a motorcycle in a long time. Okay, so determine the percent of males who are younger than 21. I got 1.3. Okay, 1.3%. Okay, the next one is different. What's different about it? We want the percent older than 38. So we go to 38 somewhere between 35 and 41. In fact, it's pretty much in the middle. So basically we want this shaded part of the data.
Well, if it's half in the middle, then what is it?
So it's like, it's going to be like 50% plus half of 34%.
Yeah.
So 50 and 17, I'm expecting maybe 67%. That's my estimate. Let's see what we get. Go to Desmos. And now, what's different about this one? This time, my maximum is infinity, but my minimum is 38. Everybody older than 38. So what did I say? Oh, I said the wrong side. I said the side up to here, which I said 67. So 67 plus 23 would be the rest. I was a bit small. The real answer is 31%. So there we go. Actually, 31.7, we'll say. So this is older. So I even shaded the wrong side.
Yeah.
Give me a mulligan on that. I just did this one wrong. So this is the line approximately, but I want this side older than, and I got, what did I get again? I got 31.7%. So there we go. Okay, guys on my TIs, how do you do that? The same way we just did the other one. Oops, come back here, TI. Okay, but this time, clear. Okay, I don't want the graph, I just want the number. Second function vars, number 2, and then this time we start at 38, comma, we go to infinity, make sure you don't put a negative on it, 1 EE99, comma, and then, what was the mean again? I've already forgotten what the mean and the median, the mean and the standard deviation are. 35, comma, 6.3, and okay, this better be 31.7%. Yep, same exact decimal. Okay, one more. Determine the percent of males who are between 30 and 40. How many 30-somethings are riding motorcycles according to this survey, this data? So this was 35, remember, and the standard deviation was 6.3. So 30 would be maybe around there. And 40, this was 41.3, so 40 would be pretty close to that. So I'm looking for this zone here. How do I do this one? On the TI, it's lower boundary 30, upper boundary 40, 35, 6.3, right? So again, that's lower boundary, upper boundary, mean, standard deviation. Question? Yep. So on Desmos, I am going from 30 to 40. It's more than half, 57.3%. On the TI, isn't that what you got? I'll check in a minute. It's normal distribution, CDF, from, okay, let me use, I can't see my 4 numbers here. From 30, comma, 40, comma, 35, comma, 6.3, close brackets and hit equals. 57.3%. And if I really needed to see it drawn, I'd have to play with my windows, clear my old drawing. Can't believe I couldn't remember that from last year, or 2 years ago. And then make a new window, right? Make a window that makes sense. Okay, so that's it for this stuff. That takes us to, there's one more lesson to go. What if we had to do this backwards? What if I told you what percent the data was and we wanted a z-score? We'll learn how to do that on Monday. Okay, I handed out a couple of things yesterday. So what you're going to do is you're going to work on them. Let's see, let me go to the blog. I have the blog open someplace. There we go. So yesterday I handed out a 5.5 assignment. Now you can't do them all yet because we haven't learned how to do the backward stuff. But you can definitely do number 1. It's just calculating z-scores. You can do number 2. It's just like the one we just did. You can do number 3. You can do number 4. And you can't do 5 yet. You can't do 6 yet. You can do 7. You can do 8. You can do 9. You can do 10. You can do 11, I think. Oh no, wait a minute. No, what mark would be in the top 5%? You can't do 11. So okay, so we need to do the next lesson before you can tackle 5, 6, and 11. But the rest you should be able to try. Okay, so I'll add that to the blog. So let me go back and open the blog again.
That's why we're doing.
Okay, so I will do that on the blog. And then, if you're finished that and you want to start getting ready for next week's test, I also gave you a review. Again, there might be a question or two at the end we haven't done yet because we still have one lesson to go. But you could get started on this weekend if you wanted to. Okay, I'm going to stop the video there. That's long enough. Thanks for watching, people who weren't here in class today.